Today, we are going to focus on solving exponential and logarithmic equations. And we're going to use what we've been learning with the properties of logs when solving logarithmic equations. And we're going to use converting between logarithmic and exponential form when solving both types of these equations. So this topic is going to be broken down into two separate videos. And this first video will focus on solving exponential equations. And there's two types of exponential equations. The first type is exponential equations in which you can get a common base. And the second type is solving exponential equations in which a common base cannot be obtained. So, first things first, let's talk about the easier one. And the easier one is solving exponential equations in which a common base can be obtained. All right? So the first thing you're going to want to do, always, is try to rewrite the bases in terms of each other. Now, some common mistakes that are made here, all right, is that people want to rewrite bases by moving up. And you cannot do that. You can only lower base values. All right? So you want to try to rewrite the bases in terms of each other. If you can, the bases cancel out and you set the exponents to each other. And then you solve. All right? So the first example of such is something like this. Let's do 16 to the 3x equals 8. So right now, the base on the left is 16 and the base on the right is 8. Those are not the same. And you cannot change 8 to 16. That is not possible. We're not multiplying bases, all right? You're rewriting them in terms of exponents. So you want to see, can you rewrite these to have the same base? And you can. 16 can be rewritten as 2 to the 4th, and 8 can be rewritten as 2 to the 3rd. That's the only common base that they have. So now we can rewrite this as 2 to the 12x equals 2 to the 3rd. Because the bases are the same, they cancel out, and we set the exponents equal to each other. And we get x is equal to 3/12, which is equal to 1/4. Now, once again, you can only lower base values. You cannot increase them. Okay? Let's try another one together. Let's say you were asked to solve 27 to the 3x equals 81. Right now, they don't have a common base, but we're going to try to get one. And we're going to recognize that 27 is 3 to the 3rd, and 81 is 3 to the 4th. This can be written as 3 to the 9x equals 3 to the 4th. The bases are the same, so we set the exponents equal to each other, and you get x equals 4/9. All right, let's look at another one. Let's look at another one together. Last one. Let's say you were asked to solve 3 to the negative 2x plus 2 equals 81. Well, this already can't be written as a lower base, but 81 can be written as 3 to the 4th. Now that the bases are the same, they cancel out, and you set the exponents equal to each other. And then you solve. 2x equals 2, x equals negative 1. All right, now that we've gone through 3 examples, it's your turn. I'd like you to solve the next 2 on your own. The first one I'd like you to solve is eight to the 3x equals 4 to the x plus 1. And the second one I'd like you to solve is 2 to the 5x plus 1 equals 32. Go ahead and try to do those now. All right, so if you did these, you would recognize that 8 and 4 have a common base of 2. So 2 to the 3rd times 3x equals 2 squared times x plus 1. Now that they have a common base, we can cancel them out, and we get 3 times 3x is equal to 2 times x plus 1. So 9x is equal to 2x plus 2. Subtract 2x from both sides. 7x equals 2, and x equals 2/7. In this second one, we can get a common base of 2 again. So it's 2 to the 5x plus 1 is equal to 2 to the 5th. So 5x plus 1 equals 5. 5x equals 4. X equals 4/5. All right. So now that we've gone through the ones in which we can get a common base, we need to talk about, well, what happens if we can't get a common base? How can we solve exponential equations without common bases? So what is something like that going to look like? Well, our first example of that is going to look like this. Solve 15 to the 3x equals 285. Now, once again, what we're solving for is x, and it's located in the exponent. All right, and that makes it difficult because we can't just move it out of the exponent. It's not possible. So we do what we did before, and we always ask for step 1, can you rewrite to have a common base? And remember, that means only lowering the base value. If your answer is no, you common log both sides. And remember, common log means a base of 10. So log 15 3x equals log 285. Now, because we have a logarithm, we could use our property of logs, and we can move our exponent into coefficient form. So step 3 is we are going to use the power property of logs to move the exponent into coefficient form. Okay, so that takes us to 3x log 15 equals log 285. So now we're going to solve for x. All right. We're going to divide by log 15 on both sides. And this is going to require the use of a calculator. And we're going to get 3x equals, and you're going to plug this into your calculator. Okay, so log 285 divided by log 15. And you're going to get 3x is equal to 2.087291136. And you don't want to round yet. You're going to round at the end. And then you're going to divide by 3. And you get x is equal to 0.695763712. Now, what happens is, all right, is remember with logarithms, we need 4 decimal places. So you're going to round to the 4th decimal place, and your final answer will be 0.6958. All right, let's do another one together. Let's look at this one. Let's solve 5 to the 2x equals 130. Okay, once again, we ask, can we get a common base? 5 and 130. Unfortunately, we can't. 130 can't be rewritten as 5 to some power. So we're going to move our coefficient, but before we do that, we have to common log both sides. So log 5 to the 2x is equal to log 130. Then we move the 2x into coefficient form and solve for x. We're going to divide both sides by log 5. And we get 2x is equal to 3.024369,199. And then we're going to divide it by 2. And we get x is equal to 1.5121846. We know we round to 4 decimal places with logarithms, and so it's 1.5122 as our final answer. All right, so now that we've done a few of those together, it's time for you to do some. So please go ahead and solve these next 2. Please solve 12 to the y minus 2 equals 20. And solve 4 to the x equals 19. Once you are done completing these 2, you can move on to the second video. All right, let's look at these 2 together. All right, so once again, we cannot get a common base between 12 and 20. So we need to common log both sides so we can move the exponent into coefficient form. So y minus 2 log 12 equals log 20. Then we're going to divide both sides by log 12. Y minus 2 is equal to 1.20557135 and then we're going to add 2 to both sides, and we get y is equal to 3.2056. All right, for our next example, once again, 4 and 19 can't get a common base. So we're going to common log both sides, and now we're going to move the exponent into coefficient form, and then divide by log 4 on both sides to isolate x. Remember, when we're in coefficient form, you're multiplying. and you should get an answer of 2.1240. All right, go ahead and watch the next video.